Hello. I have updated our course website. I announced assignment one. Later, I will explain the contents of this assignment. And if you, when submitting your assignment, you need to follow the submission rules. And I will try to demonstrate how to send your assignment. Here, I provided an email link, so you just click this link. And then the recipient will automatically be determined. And the subject line will also be automatically determined. So do not change the subject line. And then you put your name in the content of this email. And then you attach your CPP file. Remember, the file name of your CPP file, the student ID must in the beginning of the file name. So this is the submission rules. So it's very simple. You just click this email link and put your name and attach your CPP file. And remember to put your student ID in the beginning of the file name. This is because I wrote a program to fetch all the assignments. So you need to follow this submission rule. Otherwise, my program cannot fetch your assignment. You can see this page. This page describe the rules in more detail. Your assignments will not be processed if you fail to follow the submission rules. And after you send your assignments, remember to check the sent folder. If you succeed, then you can see some file in your sent folder. And you can also check your email. If you find any errors, you can fix the errors and then resend the email again. And the grading will be based on the most recent assignment I received. We can see the one image at the bottom of this page. So here is the subject line. So for assignment one, the subject line is assignment one, PROGB. For the next assignment, you change assignment one to assignment two. And PROGB is fixed for this course. So do not change PROGB. And then you put your name in the contents and attach CPP, your CPP file. Do not replace space with the underscore symbol. So because the two subject lines are different, so do not space with the underscore. And you also cannot separate assignment and the one. So uh, there is no space between assignment and one. And you can determine your file name as long as the student ID is in the beginning of this file name. So you can add any words after the student ID. For example, you can add assignment 1, version 1, or version 2. You can add any words after the student ID. You must include student ID because I write a program to automatically register the scores, and in order to know your ID, so that the program can register your scores. Below are invalid file names because the student ID is not in the beginning of this file name. So the two are invalid file names. And do not send links to your CPP file. You must send real files. So and I also suggest to show the hidden file extensions, because the Windows 10 will by default Windows 10 will hide file extensions, so you cannot see CPP or ESE. So for example, I in this folder we have 3 files. The 3 file names are the same: hello world.cpp, hello world.ese, hello world.o. If you hide the file extension, then you will not see CPP, ESE, and O. So you may not be able to distinguish the 3 files. And you need to send this CPP file, not the ESE file. And the accuracy of assignment 1 will be updated weekly until the deadline. For example, if you submit your assignment by 10 p.m. on 9/25th, so 9/25th, and then you can view the accuracy of your assignment on 9/26th. And if the accuracy is not 100 points, you may revise and resubmit the assignment until the deadline. And this policy also applies to other assignments. So if you send your assignments as early as possible, then you have more chance to revise the assignment. Next, I will explain assignment 1. Make sure to read the instructions thoroughly before you start coding. Some students in previous years do not read the instructions thoroughly, so he made some mistakes and received no points. assignment 1 is to write a program that accepts an input amount in euros. So the user will input some number. This number is the amount in euros, and your program will convert this number to the corresponding fewest number of 50, 20, 10, 5 bills and 1 coins. Below is one example. So the input number is 99. Then you convert your program should output the following. Your program need to calculate the number of 50 bills, and here is 1 because if 2 times 50 is 100, already larger than 99. So here the number of 50 bills is 1. And then the remaining number is 99 minus 50, which is 49. And the 49 you need to convert to the number of 20 bills. So here the number of 20 bills is 2. And the remaining amount is 9. So you need to convert 9 into the remaining bills and the coins. You can follow the same similar procedure to compute the number of 10 bills and the number of 5 bills and the number of 1 coins. Know that the conversion is unique. Only the conversion is unique. This means the answer we have only one answer, because this assignment requires to use the fewest number. If you choose 0, then you need to use more 20 bills or other bills. So this assignment requires you to use the fewest number of bills and coins. So the conversion is unique. I also provide more samples. You can test your program with these samples. Here I provide 10 samples. Suppose you enter 384, then your program should output the following message. So your program should output the input corresponds to 7 50 bills and 1 20 bills, 1 10 bills, 0 5 bills, 4 1 coins. So you can use the samples to test your programs. So I suggest before submitting assignments, ensure that your program successfully handles all the samples provided above. And the input is an integer, ranges between 1 and 100, 1000. And you don't need to worry about the input. The input will be always within this range. So you don't need to check the input. For this assignment, your program are required to be the outputs of your program are required to be exactly the same as loss in the provided samples. Here, exactly the same means every character in the output should be including spaces, new lines, punctuation, and letters should be identical to the provided samples. So the output, so this means your program should satisfy these requirements. If your program does not satisfy this requirement, then your program is considered as formatting has an error of formatting. So you need to ensure you follow the requirements of this assignment. And here I provide a code template. You can modify this code template so that you can follow the you can produce the correct formatting. So here is the code template. You can download this file and modify some variable names and insert your code. So here is the code template, and you can remove the comments and insert your code here to compute variable 2, variable 3 up to variable 6. So you need to perform some computation. You use just some arithmetic operations, and maybe you need to declare variables. And you can use some arithmetic operations to compute the answer to this assignment. So if you use this code template, then you don't need to worry about the output format. Below are some examples to demonstrate wrong output format. The following line is from the code template, and you cannot remove any characters inside the double quote. For example, the following produce wrong outputs because the following removes a space. The following removes a space after the column. So you see that this line removes the space after column. Although you can, so this line will produce incorrect outputs. Also, some students will add some statements after end LL after this line. For example, some students use dev C++, and this statement is not standard, and this statement will produce extra line breaks. So do not add this statement when submit your assignments. You can use this statement when you test your program, but when submitting the program, you need to remove this one. The following is also incorrect because the following line outputs extra line break. I also saw some students remove this line, remove the line corresponds to. This is also considered wrong outputs. So I suggest that you use the code template and do not modify any characters inside the double quotes, and do not remove any lines, any cout lines. Because if you remove this line, then your output formats does not meet the requirements of this assignment. And below are some suggestions. In the code template, we have 6 variables, and I suggest you to rename these variables with meaningful names. For example, you can rename variable 1 to euro amount. So this can increase the readability of your program. And remove comments. Typically, you don't need to write comments if your variable names are descriptive. So this is the principle of clean code. So I suggest removing comments. And in this assignment, we only use the integer type. So you can see in the code template, you will only use integer data type to declare variables. And also you need to declare variable 2 up to variable 6 by yourself. And you need to pay attention to the deadline. The deadline is 3 weeks later. You can also see the our schedule. I will include the deadline of each assignment in this schedule. It's usually 3 weeks later. And next, we will have a quiz. So you can test whether you can log into the Ruvio. And if you log in successfully, you can see a question open for response like this. If you log in successfully, you can see if you are seeing this message, it means you can successfully use Ruvio to take the quiz. And for the quiz, you cannot use laptop and tablet. So you need to close the laptop and the tablet until the quiz is over. You can use your laptop and tablet again. So you need to close your laptop and the tablet until the quiz is over. You need to close the laptop. Because during the quiz, we cannot use laptop. But you can use mobile phone to search the answer, or you can see your notes, but you are not allowed to use tablets. So you need to also close your tablet. So please close your laptop and close the laptop. A tablet, I cannot see whether you use this one, so you need to. Okay, and that's if you cannot use Ruvio, please raise your hand. I will provide the answer sheet. Please raise your hand if you cannot use Ruvio. Anyone? Ruvio. So you can see the course website. If you cannot log in, the Ruvio later you can try. During the course break, you can try. You can click Ruvio how to, and you will see the course title and the course code. You can register a new account or use the account provided here. But if you cannot use Ruvio, then you can use the answer sheets. And our quiz will begin. So the first question is, what is the purpose of a compiler? And the only one option is correct. If you use Ruvio, you can modify your answer many times before the end of the quiz. You can see the notes, or you can use your phone to search the answer. I will turn on the second question 2 minutes later. 20 seconds left. Then I will turn on the second question. You need to choose the wrong statements. So we have 4 statements, and choose. You need to choose the wrong statements. 30 seconds left. Next, I turn on the third question. This question is about variable name. Which of the following are legal variable name? Here, I refer to the C++ programming language. Which of the following are legal variable names in C++? 30 seconds left. And I will turn off all the questions. So you need to choose one answer. If you use answer sheets, remember to write down your name and student ID and submit the answer sheets to me. Anyone use the answer sheets? Next, let's see the answers. The first question is, what is the purpose of a compiler? So the correct answer is this, the third option. So I think most students choose the correct answer. The compiler is not to write programs. We use text editor to write programs. So the purpose of a compiler is not to write programs. Remember that recall that in the previous week we introduced IDE, and the IDE is a tool consisting of two components. The IDE is a combination of a text editor and a compiler. We use text editor to write programs, and we use compiler to convert the text file into machine codes. So text editing is not the job of a compiler. And also, executing programs is not the job of a compiler. So the answer is the third option. And for the second question, we need to choose the wrong statements. Or you need to choose the wrong statements. And most students choose this one, and this is the correct. No, this is correct. Semantic errors cannot detect it by compilers. Semantic means our intention. So semantic means our intention, and the compiler cannot detect our intention. So semantic errors are difficult to find. While syntax means grammar, and the grammar can be checked by compilers. So syntax errors are easy to fix. So among the four statements, the wrong statement is the fourth option. Next, we need to choose legal variable names in C++. And the first one is legal because you can use underscore and the digits in file name, in variable name. So A is legal. B is not legal because B return is a reserved word in C++. Recall that in every C++ program, we will have a main function, and in the main function, we have the return 0 statement, and here return is a keyword in C++. You also know that the syntax highlighting in this IDE. So we see using namespace int return are all keywords. So it is in dark blue color. You can try to declare variables. For example, I try to declare return as a variable name. And when you do this, you will see error message because C++ does not allow you to use keyword as variable name. And the third one is not legal because digit, you cannot use digit in the beginning of the file name. So C is also not legal. You can also try to declare a variable like this, 12AB. So this is not legal. We see that the compiler expect some characters before numeric constant. So this is not legal. So digits cannot be in the beginning of a variable name, but it is allowed to after some characters or after underscore. So this variable name is legal. So the fourth one is legal. So we know A and D are legal. So the answer is the second option. And you can refer to the slide in this page. This page describes the rules for variable names in C++. If no questions about the quiz, then we will return to course materials. In previous week, I introduced some concepts in programming, like expressions, statements, and I also introduced some built-in data types in C++. Recall that in C++, if you want to use variable, you need to declare it first. And how to declare a variable? You need to use data type. So you need to use data type to declare variable. And then I will introduce the built-in data types in C++. This slide summarize the built-in data types in C++. We have integers, floating point numbers, and the characters and the Boolean data type. For integer, we have three data types: short, int, and long. Both three data types are integers, but they may have different memory size. Usually, the memory size of int is larger than that of short. The memory size of long is larger than that of int. And for the integer type, we also have one keyword unsigned. If you prefix unsigned keyword before integer data type, then this means this data type can only deal with non-negative values. I will use one example to illustrate this. Now suppose we declare unsigned int. And we assign some value to this variable. So here x is a variable. Its data type is unsigned int. Then we can print its value. So you see that its value is 10. Now suppose you assign a negative number to this variable. And let's see what happened. You see that the output, the value of x is not negative 10. It's some large number. This problem is known as overflow, because unsigned integer can only save non-negative values, and non-negative means larger than 0. So you cannot save negative values in unsigned integer. If you do this, you will encounter overflow. So some unexpected behavior happens. So you must choose the right data type for your task. But if the data type is integer, this data type can deal with negative numbers. So we need to rebuild this CPP. So you see that if the data type is integer, then the value of x is negative 10. So integer, for this data type, it can deal with both negative and the positive numbers, values. I think time is up, so we can take a break for 10 minutes. Hello, and let's continue our class. In previous week, we know the integer data type, the memory size of integer data type may be inconsistent across different operation systems. For example, the long data type has different memory size on different operation systems, and this can cause the portability issues of your programs. And to solve this problem, the C++ committee in 2011 introduced some new data types. These data types known as fixed width integer data types. So you can infer from the name of the data type. So for example, integer 8 means 8 bits. So this data type has 8 bits, and 8 bits corresponds to 1 byte. And so we can infer the memory size from its data type, from the name of the data type. And this can resolve the portability issue of integer data types. And also recorded in the previous week, you can go to the syllabus. Here is the syllabus, and here is a reference. This page contains the references of this course, so you can go to this page. And under the C++ basics item, you can find the binary and decimal. And this link introduces how to convert from binary to decimal, and vice versa. Because in C++, sometimes we will deal with binary number system, so you need to understand what is binary number system. Here is a quick review. For example, you write for decimal number system. When we write 123, this means 1 times 100 plus 2 times 10 plus 3 times 1. So this is what we mean in decimal number system. For decimal number system, the base is 10. But when we use the binary number system, the base changes from 10 to 2. So for binary system, the digits. So for binary number system, you see that its base is 10. Is 2. Its base is 2. And you also notice that each digit, the range of each digit is from 0 up to base -1. So for binary, the digit can be only 0 or 1. But for decimal number system, each digit ranges from 0 up to base -1. So each digit is 0, 1 up to 9. And if you represent a binary number like this, then you can calculate the corresponding decimal value. So this means 0 times 2 raised to 0 plus 1 times 2 raised to 1, and up to 1 times 2 raised to 5. So this number, this binary number represents 32 plus 2. So this binary number represents 34 in decimal number system. And you can do more exercise, or you can do more exercises to practice how to convert from binary to decimal, and vice versa. And here is one additional link. You can use this link to verify your answer. For example, now I want to. You can write down any binary number. For example, 101. Then you can determine its equivalent decimal number. So this means 1 times 1 plus 0 times 2 plus 1 times 4. So this corresponds to 4 plus 1, which is 5. So the answer should be 5 in decimal. So you see that this binary representation corresponds to 5 in decimal number system. So you can use this website to practice to convert from binary to decimal. And you can also perform the other direction. For example, now suppose we want to convert from 34 in decimal. We want to convert this decimal number to binary. Then we see that 34 corresponds to 1 0 0 0 1 0. And the detailed process is this page also shows the detailed process. For example, it shows how to convert 34 to 1 0 0 1 0. Actually, you will perform division by 2, and you will obtain the remainder. And after you obtain the remainder, you obtain the binary representation. So the binary representation is 1 0 0 0. You need to know the direction is from this place. The direction is from this place, 1 0 0 0 1 0. So you can follow this procedure to convert a decimal number to its binary representation. I will try another example. For example, I want to convert 23 to binary. So 23 is 16 plus 7. Then you decompose 7. So 7 is 4 plus 2 plus 1. All right. So you just decompose the number into the powers of 2. Into the powers of 2. Then you use the power index to form its binary representation. So its binary representation should be 1 0 and 1 1 1, I think. So you can use the website to verify your answer. So now suppose I type 23, and you know that its binary representation is 1 0 1 1 1, which is the same as my calculation. Because in C++, sometimes we need to deal with binary representation. I will use one example. For example, here suppose we have this number, and its binary representation is its binary representation is 4 plus 1. So its binary representation is 101. Right? Because this 5 is 4 plus 1. So its binary representation is 101. And in C++ or in C, you can perform shift. You can perform, for example, I can shift X, left shift. You can do either left shift or right shift. When you perform left shift, this means you left shift 101 by 1 bit, so the number becomes 1010. So if you perform left shift by 1, then this means its binary representation is left shift by 1. So the result is 1010. And then this is binary representation. So what is its decimal its decimal equivalent? Its decimal equivalent is 8 plus 2. So this number corresponds 10, right? So this binary representation corresponds to 10 in decimal. So if you print the value of x should be 10. So if you perform this left shift operation, you are dealing with binary representation. Next, let's return to this page. So next, suppose we use unsigned int integer 8 to declare variable. Here u means unsigned, and unsigned means the data type can only deal with non-negative values. So here u means unsigned. Suppose we have 8 bits, then we need to determine its size range. We know that if you have 8 bits, and each bit can be either 0 or either 1, so you have 256 possibilities, because 2 times 2 up to 8 times. So you have 2 raised to 8 number of possibilities. So you have 256 possibilities to represent a binary number. So for unsigned int 8, you could represent 256 possibilities. And the size is usually begins from 0 for non-native numbers. So the size range is from 0 up to 255. So if you know its memory size, you can compute its size range. This also applies to larger data types. For example, unsigned int 32 corresponds to size range from 0 up to 2 raised to 32 minus 1. here we have -1 because we begin from 0, so we need to add the -1. And the same procedure applies to unsigned int 64. Its size range is 0 up to 2 raised to 64 -1. Then we can determine the integer 8. We can determine the size range of integer 8. Recall that integer 8 includes both negative 0 and the positive values. So its size range deal with negative numbers. So here we need to divide the size range by 2. So you divide 256 by 2, then you obtain 128. So the size range begins from negative 128 up to 128 -1, because we need to include a 0, so you need to -1. And also the same, you can apply the same process, assign the same steps to compute the memory size, the size range of integer 32. It is from this number. This number is 2 raised to 32, then divided by 2. So its power is 32 -1. So its size range begins from negative 2 raised to 31 up to 2 raised to 31 -1. So you can use the same process to compute the size range of integer data type. It is important to know the size range, because if the value is outside the size range, it can cause overflow. Just as I demonstrate, if you use unsigned int 8, then suppose it is outside the range, then this will cause overflow. Here I perform typecasting to show its integer value, because if your data type is unsigned int 8, it will be treated as a character. So sometimes you cannot see its numerical value. So in order to see the numerical value, you need to perform typecasting. So we see that overflow occurs because -1 is outside its size range. So you need to choose the proper data type for your task. Next, let's talk about another built-in data type. Let's talk about floating point data type. When you want to deal with floating point numbers, you need to use floating point data type. And we have two data types in C++. We have float and the double. Its memory size is fixed across all operation systems. Because this is defined, the formats of the two floating point data types are defined by IEEE 754 by this standard. So its memory size is always fixed. Float always has 4 bytes, and the double always has 8 bytes. But its its size range is different from integer. It's very different. So you can see that its size range is very large. Only 4 bytes is size range from 10 raised to negative 38 up to 10 raised to 38. So this is a very large size range compared to this one. This is much smaller. So the size range of the floating point data type is different from is very different from integer data types. This is because the floating point data type use a different strategy to represent a number. Let's see it's how float can represent a number, a floating point number. The float has 4 bytes, and 4 bytes means 32 bits. So float has 32 bits, and we usually we have index from 0 up to 31. So the 31 bit is its sign. Sign can be positive or negative. So if sign is positive, this means positive floating point. If sign is 1, if sign is 1, then this means this floating point is a negative number. And the next 8 bits, so the next 8 bits is from 30 up to 23. So the next 3 bit represents exponent, and the remaining 23 bits represents fraction. And so this representation is known as scientific notation, scientific representation. So this representation could represent a very large number or very small number. So its size range is very large. And you can try, and because the conversion, because another course will discuss the floating point. So in this course, I will not talk too much details about this data type. And you can find in the references page, you can find a link to a float converter. You can enter some number. Some floating point number or integer. Then this tool will convert this decimal value to its binary representation. So let's convert this. So we see that this decimal number is converted to 32 bits. So if you use float to store 5, then this 32 bits will have this binary representation. This corresponds to this number is the binary representation in float. Let's try some other value. For example, you want to save 3.14. You see that its binary representation is this one, and we pay attention to that. The value actually stored in float is close to the number we entered, but there exists some minor errors. You notice that if your binary representation is this one, then the value actually stored in float is this number, not 3.14. So the two numbers has some small errors. The errors is these numbers. So you pay attention to that. The floating point data type is not precise. You might lose some precision when you perform floating point arithmetics. If you want more precision, if you want higher precision, then you need to use you can use double, because the precision of double is higher than float. Because double has 8 bytes and the float only has 4 bytes. So if you want more precision, then you should use double. The precision is up to 15 digits from the floating point. So if you use double, the precision is up to 15 digits. And in C++, we have the size of operator. So you can use this operator to know the memory size of a constant or a variable. For example, I can use the size of then this operator will return the memory size of x in bytes. So this will return 1 because unsigned int 8 is 1 byte. So you see that it returns 1. 1 means the unit is in bytes. You can also try some constant. For example, you can try 10. So integer data type has 4 bytes. So this operator will return 4. So we see that because 10 is an integer data type has 4 bytes. So size of 10 returns 4. You can also try some floating point number. So let's try this floating point number. And we see that size of floating point number return 8. And you can think reason why this expression returns 8. This means this floating point is float or double. Must be float, must be double, because double has 8 bytes. So if you write a constant, a floating point constant, then its data type is double. You can also use size of to test the memory size of other data type. Later, we will introduce how to define our own data type. So in later lessons, we will learn how to define our own data type. And you can also use size of to know the size of other data type. In C++, 2011 introduced some new features like auto. Auto is a keyword, and here is declare type is also a keyword. This keyword is very convenient. It can automatically determine the data type of a variable based on the value on the right hand side of an assignment. Here is one example. Now suppose you want to declare a floating point, double x so now suppose we want to declare a floating point. You can use double, or you can also use auto. Auto will automatically determine the data type based on the value on the right hand side. The value on the right hand side is a double, so compiler will automatically determine the data type of x as double. And this feature is very convenient when you deal with some very complex data types. Next, let's talk about how to initialize variables. So we know how to declare variables. So you declare variable. If you want to use a variable, you need to declare it first. Then you assign some value to it. So the first, so this statement is known as declaration. So this statement is known as declaration. When you want to use a variable in C++, you need to declare the variable first. And the second statement is known as assignment. You assign some value to this variable. And you can combine the two operations in one line. So you can combine assignment and declaration in one line. And this means so this line means you assign some value to this variable as its initial value. So the initial value of x is 12. Now suppose I do not give any initial value. So suppose I only declare it, but I do not initialize this variable. Can you know its value? Does anyone know its value x? If I do not initialize this variable, do you know its value? Of course, you can compile and see the answer. So let's see the answer. The answer is we don't know. If you declare a variable and you do not initialize it, then you do not its value. So its value is a unknown number. And this is common mistake for beginners, because beginners usually declare some variable and without initialization and start to perform some calculation, because, for example, you try to perform some arithmetic. So it's common mistake to write code like this. So some beginners think, if I do not initialize this variable, the value should be 0. So some students, but this is not true in C++. In C++, if you do not initialize its value, then its value, you cannot assume its value is 0. So you see that its value is some random, some unknown number. So it is a good habit to always initialize a variable. You can initialize to 0. So it is important to initialize a variable, because if you do not perform initialization, then you do not know its initial value. And this is a common mistake for beginners. And I saw a lot of errors in assignments. And you have another way to initialize a variable. You can use parentheses. Inside the parentheses is the initial value. You can also use this method to initialize a variable. This is known as constructor. Later we will also learn constructor in our final class. This is known as constructor. And below are some more assignment statements. For example, you want to perform count plus 2 and assign this value to count. And we have a shorthand notation. You can use plus equal. You can use this operator. Plus equal is one single operator, and this operator means you perform addition first, and then assign the result of the addition to this variable. So we have similar shorthand notations like minus equal, which means you perform you perform subtraction first, and then assign the result to the total variable. And we also have multiply equal and divide equal. We also have these operators. When we perform assignment, we need to pay attention to that, to to consistent data type. So you need to ensure the data type on the right hand side is the same as the data type on the left hand side. For this example, we have type mismatch because on the right hand side is a floating point number, but on the left hand side is an integer. So the data types are different. So we can try this example. We have. So do you know what is the value in x? What is the value in x? We on the right hand side we have a floating point number, and on the left hand side we have an integer. So what is the value of x? You can compile and see the results. It's 3. It's 3. So if you assign a floating point number to an integer, the value after the floating point will be discarded. You can try other numbers. So for example, 3 point. So the value of x is also 3, because the number after the floating point will be discarded. So the value of x is 3. So it is important to know the data type of a variable, because the behavior of each data type is different. So you need to understand the behavior of each data type. And if you assign integer to floating point, and this is okay, because the integer will be converted to a floating point, and then the floating point number is assigned to this double variable. So if the right hand side is integer, left hand side is floating point, this is okay. Let's talk about assignment statement. When you perform assignment like this, the right hand side is usually an expression. Expression means any operation that can generate a value. So this is expression. So expression will generate a value, and you can assign this value to some variable. And because this value is on the right hand side, so this value is also called R value. And on the left hand side is a variable. Variable means this variable means you can change its value. So the on the left, because variable is on the left hand side, it also called L value. The left hand side cannot be a constant, so you cannot assign some value to a constant, because a constant cannot be modified. So you can try so you can modify a value of a variable. So in this statement, we modify the value of a variable, but you cannot modify the value of a constant. Uh, you cannot modify a value of a constant. This you can see the error message. The error message is the L value. L value is required, and the L value must be a variable. Because if you perform assignment, you want to change the value. So so L value must be a variable. Assignment can also be used as expression. This means assignment, after you perform assignment, assignment will generate a value, and you can use this value to perform other operations. But this is not recommended because the readability of this usage is very low. So I do not recommend you use the assignment as an expression. And next, let's talk about constants. Constants, also known as literals. So the two words are used interchangeably. So constant is in contrast to variables, which means you cannot modify the value of a constant. We have floating point constant. When you want to express a floating point constant, you have two choices. You can use the floating point notation, or you can use the scientific notation. The floating point notation is like this. For example, 3670.0. This is known as floating point notation. Or you can also use the scientific notation. Scientific notation is like this: 3.67 E3, and E3 means you multiply 10 raised to 3, which means you multiply 1,000. So you have many equivalent ways to express a floating point constant. And the floating point constant in this line are all the same, all express the same number, 3,670. If you want to use the scientific notation, you will use the small e. And here e can be either in uppercase or lowercase. And the follow e, you can use a positive sign or a negative sign, or you choose to not use both. So time is up, so let's take a break for 10 minutes. Hello, and let's continue our class. We talk about constants, and you have two ways to express floating point constant. You can use floating point notation, or you can use scientific notation. And actually, other programming languages use the same notation. So if you use other programming language, the floating you can use the same way to express floating point constants. Next, we have other constants like character. So for character are enclosed in single quotes. We also have strings, and the strings are enclosed in double quotes. The two data types are different. Later we will cover more about strings in later chapters. We will learn strings in later chapters. So if you don't know strings, it is okay. Later we will I will introduce more details about strings. And for now, you just know strings are constants, and which are enclosed by double quotes. And character constants are enclosed by single quotes. And we also have two Boolean constants, true and false. Here, true and false are keywords, and the two keywords are Boolean constants. So you can declare a Boolean variable. You can assign some constants. So you can assign true. You see that true is a keyword. So you can see the syntax highlight. It becomes dark blue. So you can. So the numerical value of true is 1. So if you print x, you will see its value is 1. So another constant is false. So this is also a keyword in C++. And if you print its value is integer 0. Next, let's talk about escape sequence. First, I demonstrate one example. Now, suppose I want to print some message in the console. Suppose you want to show some message. So this message prints hello world in the console. Now suppose you want to print the double quote. Suppose you want to print the double quote after hello. And if you do this, you will encounter syntax error. So you see that if you do this, you add a double quote after hello, then you have the error message like this: missing terminating double quote. This is because if you do this, then this is a string, and after the string you have another string, but this string does not is not enclosed by two double quotes. So the syntax is not correct. and the compiler shows some error message. And if you want to print this double quote, you need to use a escape sequence. Escape sequence means you use a backslash. So you use a backslash before this character, then you can print the double quote. So we see that you print the double quote in the console. So this is known as escape sequence. And in fact, we have other escape sequence. For example, you can use \n. This means new line. So this escape sequence is equivalent to end of line. So this will print a line break. So you see that we add a escape sequence \n. Then you see that after hello is a line break. And in fact, we have many escape sequence shown in this table. We have tab or you want to print a backslash. So suppose you want to print a backslash, you need to type the double backslash. So you see that if you want to print one backslash, you need to type two backslash, because the two consecutive symbols is considered as only one character. So this is considered as only one character. And if you do programming, you need to pay attention to two slash. We have slash. This is normal slash, and this is backslash. So the normal slash is for division. When you perform division like 2 divided by 10, you will use this slash. And this one is backslash. We usually use backslash for escape sequence. So when programming, you will use the two different slashes. So this is the normal slash. This is the normal slash, and this has no effect. It's just a normal character. So this is not escape sequence. So this is not escape sequence. So this is just a normal character. So you need to distinguish the backslash and the slash. The two characters are different. If you want to use the escape sequence, you need to use backslash, and to follow the backslash is the character you want to add. For example, you want to use new line, then you add n after the backslash. You can try to use size. So this is only one character. So its size is 1 byte. This is only 1 byte because the two backslash represents only one character. So its memory size is only 1 byte. So although you type 2 backslash, but it is considered as only one character. And similarly, when you type \n, this also represents only one character. So it occupies, so its memory size is only 1 byte. You can skip the following two examples because these are more advanced. So you can skip the two examples. And the next, I will introduce how to name constants. How to name constant. When you do programming, you usually need to access a constant many times. For example, I use the constant 20 to represent the number of students, and I might need to access this number many times. So you might use these constants many times. So you see that I use the constant 20 3 times. And this is very inconvenient because if you want to change the value of this constant, you need to modify each line. So for this problem, to solve this problem, you can use naming constants here. You can use this technique. And how can you give a name to a constant? So how can you give a name to 20? You say, oh, I can use variable, so I can define a variable, for example, number of students. So I declare a variable, and I assign 20 as its value. So you can so you can reuse this variable. So you can reuse this variable. So you can reuse this variable. And later, if you want to modify this value, then it is very convenient. You only modify this line. Oh, sorry, I made a. But this approach has one problem, because this variable is not a constant. This variable is not a constant, which means someone might modify this value. So this variable is not a constant. How can you declare a constant with a name, but its value cannot be modified? So to do this, you can use another keyword, const. Const is a keyword. So you can prefix this one, prefix the const keyword before the data type. Then this data type becomes read only. So you can, if you add this keyword, then you cannot modify its value. For example, I try to modify its value, then the compiler will show some error message. You see that the error message shows assignment of read-only variable. So if you declare a variable like this, you add the const keyword, then this variable is read-only. You cannot modify its value. So it becomes a constant. But this constant has a name, number of students. So this is known as naming constants. And it is common practice to use naming constant in our source code, because this is a good habit. If you use naming constants, this can increase the readability of your source code. So it is common practice to use naming constants. And we usually following one convention. If you define a constant, we usually use the variable names are all in uppercase. This is a convention. So if you follow this convention, then other will know this variable is a constant. So we should not modify this variable. This is a convention, not enforced by the compiler. So if you need to use a constant many times, you can consider to declare a constant, naming constant. And next, let's talk about precedence. When you carry out some expression, like this one, x plus y times z, then we have two operations. We have addition and multiplication. And you need to decide which operation will be carried out first. So you need to decide whether addition or multiplication will be carried out first. And this is known as precedence. And actually, the precedence in C is according to a table. So you need to look up the table, the precedence table. So you can search. You can search the precedence table in C++. Then you can find the precedence of each operator in this table. And in this table, you will find multiplication has highest precedence than plus. So multiplication will be carried out first. And after multiplication is carried out, then this multiplication will generate a value. Then this value is added to x. So we see that this is the precedence table. And you can find the multiplication is of precedence 5 and is higher than the precedence of the addition operator. So multiplication has higher precedence than the addition operation. So this is consistent with our intuition, because when we perform arithmetic, we know multiplication has higher precedence than addition. If you want to change the precedence, you can use parentheses. For example, you want to perform addition first, then you can add parentheses around x plus y. And this is also what we do when we perform arithmetic operation. So if you want to change the precedence, you can insert parentheses. But if you don't use parentheses, then the precedence will be determined by the precedence table in C++. Next, let's talk about division. Integer division is different from floating point division. And let's see one example. For example, you want to perform 5 divided by 2. So the result is not 2.5. The result is 2. Because this division is integer division, and the integer division only generates integer value. So we see, if both numerator and denominator are integers, then this division is integer division, and the integer division only generates integer value. And in fact, integer division discards the part after the decimal point. So if the result is 2.5, then 0.5 will be discarded. And if you perform 11 divided by 3, its result is 3.66. And the part after decimal point will be discarded. So the result is only 3. So if both numerator and denominator are integer, then the division is integer division. However, if either one is floating point, for example, if the numerator is a floating point, then this division becomes floating point division. And we see that the output, the floating point division generates this floating point number. So floating point is performed if either numerator or denominator is a floating point. And you can perform expression like this. For example, you want to perform consecutive division. And in this expression, we have two operations. We have two division. Then you need to decide which division will be carried out first. And because the two are the same operation, and the leftmost operation will be carried out first. So first we will perform this division first. We will perform 1 divided by 2. And we know both numerator and denominator are integer. So this is integer division. And so we have 0.5, and we discarded the part after the decimal point. So we have 0. So 1 divided by 2 is 0. And then you perform this division. This division is floating point division because the denominator is a floating point, and the result is 0. And we know that for the integer data type, we also have one operation. This operation is known as the modular operator. You can use the modular operator to compute the remainder. So for example, 5, if you want to calculate the remainder of 5 divided by 2, which is 1, then you can use the modular operator. So the remainder is 1. And only integer variables has this operation. And for floating point data types, you cannot use the modular operator. In fact, we have this relationship. This relationship use integer division and also use the modular operator. You can notice that 5 equals 5 divided by 2. This is the quotient of 5 divided by 2. So 5 equals quotient times 2 plus the remainder. So this is the basic division method. So the 5 can be written as the quotient of 5 divided by 2 times 2 plus the remainder. And you can use the integer division to obtain the quotient. And you can use the modular operator to obtain the remainder. And in fact, you can try this. So for example, so here I perform integer division to obtain the quotient. Then I use the modular operator to obtain the remainder. So you can so do you know the answer? The answer is 17. Right. Answer is 17. You can change to any number. For example, 1, 2, 3, 4, 5. The answer is 1, 2, 3, 4, 5. Because this is the basic integer division, and maybe you can refer to this page. I think. For example, you can refer to this page. For example, you input 13, and the quotient of this is 6, so the quotient is 6, and the remainder is 1. So 13 can be expressed as quotient times 2 plus the remainder. The next slide introduce a pitfall when you deal with integer division. Let's see an example. And in this example, we calculate price 1 and price 2, and the calculation are similar. For price 1, we compute feet divided by 30, and then we multiply the result by 300. And price 2 is the same, but the only difference is that the data type. For price 1, we use floating point 30, which is floating point. For price 2, we use 30, which is an integer. Then if you run this code, you will notice the value of price 1 and price 2 are different. Price 1 is 1,000, but price 2 is 900. So if you don't pay attention to integer division, you will encounter problem like this. So we see that we can calculate this first. So let's calculate price 1 first. And because of the parentheses, its precedence is higher than multiplication. So we compute this division first. Then we need to determine this division is integer division or floating point division. And obviously this is floating point division. So the result is a floating point. It is 100 divided by 30. It's a floating point. Then you multiply 300. So you obtain 1,000. So price 1 is 1,000. Then we compute price 2. We know that this division is integer division. So we have 100 divided by 30. Its result is still an integer, which is 3, because this is integer division. So this result is 3. And the 3 times 300, we have 900. So although the two expressions are similar, but the results are different. So you need to pay attention to the difference between integer division and the floating point division. And you can try to practice this example. So you can print the value of price 1 and price 2. So we see that price 1 is 1,000 and price 2 is 900. And here I have another question for you. You can try to determine this one. Here is a question. I declare a variable feet. Then you need to compute the value of feet divided by 3. So do you know the answer? So you think this division is integer division or floating point division? If you think this division is integer division, please raise your hand. If you think this division is integer division. Oh, 1 person, 2 person, 3 person, okay, 4 person, okay. If you think this division is floating point division, please raise your hand. Okay, more people think this division is floating point division. Then let's take a look. Let's see the answer. You see the answer is 3. So this means this is integer division, not a floating point. So don't be confused by this floating point number. You need to pay attention to its data type. You know the data type of feet is integer. So both numerator and denominator are integer. So both numerator and denominator are integers. So this division is integer division. In fact, when you perform this line, first this floating point will be converted to integer. So when you write this statement, first 10 will be converted to integer, and then integer 10 will be assigned to this variable. So when you see statements like this, you need to pay attention to the data type of the variable, not its initial value. Next, let's see more about division. Let's see more about division-related topics. Now, suppose we want to you want to declare a floating point, and its initial value is determined by integer division. So you want to assign the result of integer division to this floating point. But you want this, you don't want, but you want you to use floating point division. You don't want to use integer division. However, both the numerator and the denominator are integers. So this means this division must be integer division. So how can you transform this division into floating point division? You can here I use this example. Here I declare feet as 10. So this is integer division, and if you want floating point division, you just add a floating point. So you obtain floating point division. So here I obtain floating point division. But if you use variables, but here suppose I use variables int x. Then here I replace by x divided by y. So here is always integer division because the data types of x and y are integers. So the result is integer division. And how can you obtain floating point? So if you want to perform floating point division, how can you transform this division? You cannot add a floating point because this is not constant. Because this is not constant, so you cannot add a floating point. And in this case, you need to perform typecasting. So you need to transform the data type from integer to double. So you can perform typecasting like this. You can transform the data type. The data type is integer. If you want to transform to double, you can use this this keyword, static cast. This is a keyword defined in C++. So you can perform typecasting like this. You can static cast, then followed by angle brackets, and inside the angle brackets is the data type you want to cast. And then you also need a parenthesis. The syntax is very ugly. It's hard to remember. So if you do this, you can obtain floating point division. So you obtain floating point division. In fact, you have another way to perform typecasting. I will show another way. Another way is to so you just prefix the variable with a parenthesis, and inside the parenthesis is the data type you want to cast. So in this way, you can also transform the data type of x to double. So in this way, you can also perform floating point division. So we have two ways to perform typecasting. You can use this way, or you can use this one. This one is actually from the C programming language. So this typecasting is from the C programming language, and this keyword static cast is from C++. So static cast is C++ style, and parenthesis is C style. Although C++ style is more ugly, but C++ style has some benefits. Because C++ style can be checked during compile time. We mentioned compile time and runtime in the previous week. So in the previous week, we know compile time, runtime. Compile time means the period you compile your CPP file, and the runtime means the time the period you run your executable file. And if you use C++ style, then this style will be checked during compile time. However, if you use C style cannot be checked in compile time. C style will be checked during runtime. And we know it is earlier to check this expression is better. So C++ style has this benefit. And also C++ style is easy to find, because if you want to search where you perform typecasting, you can search the keyword static cast. But if you use C style, it is hard to search, because if you search double, double is a data type. So this is the benefits of C++ style. So if you want your source code to be more robust, then I suggest use C++ style. But if the source code is for personal use, then you don't care about too much. You can choose the C style, because this is easier to write. Next, I will introduce another operator in C++. If you pay attention to the name of the programming language, you notice plus. In fact, plus is one operator in the programming language. So I will introduce what is plus. Plus is one operator, and this operator means h1 to the value of a variable. So if you perform x plus plus, then the result is x added by 1. So the result is 11. And for this example, you can also write plus x. The results are the same. For this example, the results are the same. So, but this is equivalent to write s equals. This is equivalent to you assign x plus 1 to x. This is equivalent to this statement. However, if you use this operator, if you use plus in some more complex expression, then n plus may be different from plus n. And in next week, I will introduce the difference between n plus and plus n. And I think today's class is over, and we can now dismiss.